Next speaker will be Iosu Cendoya. He's from Tech, and he's a BATSS project coordinator. I would like to remind the participants that if you have any question, this will be very helpful if you express to which project is addressed this question in the chat. This will be very helpful for the Q&A session. So, Iosu, I don't have anything else to say, so the floor is yours. Welcome.
Okay, thank you very much. First of all, thank you for arranging this webinar and inviting us to this webinar. And yes, next slide, please. My name is Iosu Cendoya. I work in CIDETEC, which is a research institution in San Sebastian in Spain. And yes, and this topic, this BATSS name states for Safe, Efficient Battery System based on Advanced Cell Technology. The cell technology we are using, it is Gen 3B, okay, and we are working with cylindrical cells. As you see in the duration of the activity, we just started in January, and the project will last for 3 years. As you see on the right, we have partners from several countries. We have from Austria, AIT and MIBA Battery Systems, from Germany, Accurec, VUV from Belgium, IFPEN from France, FPT from the Iveco Group from Switzerland, and then from Spain we are UNE, C Automotive, Lomartov, and CIDETEC. The funding is about 5 million euros from the European Union, and there is also an additional funding from the Swiss government. And the main goal of the project is to design and manufacture a battery system based on the cell-to-pack concept, and with a special emphasis on covering the safety events, and especially fire and thermal propagation. And the aim is to be, let's say, useful for several types of transport and mobile applications, and the integration in the vehicle, in this case, is not included in the project. Next, please. So we are not starting from scratch. We start from a concept of one of our partners, which is the macro cell concept of MIBA battery system, and the aim finally is to reach TRL 5. We will simulate the whole system, but regarding physical devices, we will finally demonstrate the concept with 5 to 10 kilowatt hours prototypes of up to 400 volts. And the main key innovations that we are proposing or developing in this project are, from the thermal point of view, we will use a flex cooler device, which is a specific development of one of our partners that is sticking very well to the cylindrical cells in order to improve cost, efficiency, arrangement time, weight, and safety. And we will also optimize the thermal management system through 1D and 3D modeling of these events that I talk about, and also the usual operation of the battery. From the mechanical point of view, we will take care of selecting the minimum amount of elements, and also elements that are environmental friendly, taking also a look to the cost, weight, and of these elements. And we will include, as I said, elements that are useful in order to avoid thermal propagation and fire barriers. I must say that the flex cooler itself has already some properties in order to avoid this thermal propagation, but it could be necessary adding additional ones. We will see, depending on the simulations that we will execute. And from the electrical point of view, we will customize the bus bars to optimize the space, to make them multidisciplinary. We will work also on a DC-DC converter, and a bidirectional DC-DC converter. We will introduce the silicon carbide technology in the power switch device, and we will work on we will work with ultrasound sensors and ultrasound wireless technology. All of this attached to a predictive thermal management system, and we will be aligned with the ongoing activity on the battery passport concept, and we will also take care of the end-of-life activity by proposing a self-made software. Please, next, please. So These are the 3 use cases that we have in the project. We will have we are having a construction vehicle and a leisure boat as first life, and for the second life, a stationary application which is called Vault Station. So we will also take care of this shift between the first and second life, diagnostic, how to do it, disassembly, all the matters that are related to this shift, and we will analyze the system, as I said, from the mechanical thermal point of view at 3D level, and then we will produce some samples of 400 volts in order to test it and as a proof of concept of the overall design that we are proposing. And this is all. As my colleague said, we also will be in the Batteries Innovation Day in Barcelona. So then, or whenever you want, you can access us by checking the email that you will see afterwards, or by checking the website. And that's it. Thank you, Daniel.
Thank you, Iosu.